Good afternoon, everyone. Today we are looking at some function f of x that we are told crosses the point, i.e. goes through the point, -1, 6. And we're looking to find its image point, i.e. the point it gets mapped to, when we take the function g of x, which is the resultant transformation on the function f of x, described by -3 times the square root of f of -2 times x minus 3 plus 1, and finally, plus 2, okay? So first off, we would be wise to write down some mapping rule. And so our mapping rule for some point on the original curve f of x with coordinates x and y will be mapped to. Let's figure this out. So what's going on inside of the function f? You notice that in the original function f of x, f of whatever is inside of the brackets is only x. In g of x, f of the stuff inside the brackets is now -2 times x minus 3. So writing this in transformational, taking this from transformational form onto a mapping rule means we have to reverse everything. And so we're going to write this as the x coordinate gets mapped to -1/2 times x, and then plus 3. Okay, so that's everything that the x coordinate goes through, because that is what is inside of the brackets f of whatever it might be. What used to be simply x inside the brackets is now -2 bracket x minus 3, and so putting that into a mapping rule, we take the reverse, quote unquote, of the -2 and of the -3. Now, what's going on with the y coordinate? Well, when you have the function f of x, you know that the y coordinate is defined by this function of the x coordinate. And so what we have here is this f of -2 bracket x minus 3, that is the old y coordinate. That f of whatever the stuff inside that bracket might be, that's our old y coordinate, okay? And so what g of x is a transformation of -3 times the square root of the old y plus 1, so -3 times the square root of y plus 1, and then outside of all of that, an additional plus 2 at the end. And that's our mapping rule. So now that we have that established, mapping any particular point on the original function f of x is not all that difficult, right? We're going to put it through the mapping rule and see what comes out of it. So our specific point on f of x, -1 and 6, will be mapped to the x coordinate will become -1/2 times -1 plus 3, and the new y coordinate will be -3 times the square root of 6 plus 1 plus 2, which is the point -1/2 times -1, that's positive 1/2. 1/2 plus 3 is 3.5. And then the y coordinate will be -3 root 7 plus 2. You can tell that I did not choose these numbers as wisely as one could have, but we could leave our answer in this form. Root 7 is roughly 2.6. So if we really want some decimal approximation, we could make this point be at 3.5, comma, 2.6 times -3 is roughly 7.8. So -7.8 plus 2 is roughly at -5.8. And so this would be our decimal approximation for the image point of -1 and 6. I apologize for the not so nice values, but I hope that this illustrates an important concept, and I hope that this helps develop your understanding of how we map functions, no matter how messy the transformed function might look, right? If you remember that the f of x is the original y-coordinate, no matter what transformations have been done inside of f of x, anything that's inside the brackets simply takes place on the old y. And so f of anything inside brackets is still simply a representation of the old y-coordinate. And so the stuff inside the brackets provides us with our mapping of the x-coordinate, and everything else that's done outside of f of those brackets is done on the old y-coordinate. Whatever else is going on, you simply put it onto the old y-coordinate like we've done here. So again, I hope this helps. If you guys have any questions, comments, suggestions for more videos, please let me know with a comment below. And thanks always for watching.